have the last presentation of this extremely interesting session. The paper is by Lina, Changping, Meng, Jennifer Brennan, Jean Pouget-Abadie, Ningren, Shuchao B, Yajun, Peng, Country-diverted experiments for mitigation of network effects. Let's leave the stage to Lina.
Hi, everyone. Thank you for the introduction. So, hi, my name is Lina, and today I'll be talking about country-diverted experiments for mitigation of network effects. The screen keeps blacking out. How do I go to the, oh, sorry. Yeah. So to give some context, for large content platforms, user/cookie-diverted A/B experimentation has become the gold standard for evaluating the impact of recommend system changes on audience behavior. And the primary quantity of interest is typically the average treatment effect, which is the difference in the average outcomes between applying the treatment to all users versus applying the treatment to none of the users. So a key assumption for valid inference of an A/B experiment is the stable unit treatment value assumption, or SUTVA. And SUTVA requires that each user's outcome is independent of the treatment assignments of all other users. And then under SUTVA, the standard average treatment effect estimator is unbiased as the sample size approaches infinity. However, despite its gold standard status, SUTVA is often violated to varying degrees in user-diverted experiments. To see this, one can imagine that all users of the content platform being nodes in a large network with the edge weights corresponding to the degree that two users are similar to one another. And then due to feedback loops, this network informs future recommendations and thus the topology of the network at future time points. So if you and I are very similar, we're likely going to be recommended similar kinds of content, and then that will further reinforce our similarity to each other. So what happens in a cookie or user-diverted experiment is that users with very similar consumption patterns can be assigned to different treatment arms. So users in the control can receive some form of the treatment despite not being directly treated. And this violates SUTVA. So for example, suppose you and I are very similar. I get assigned to the treated arm, you're in the control arm. And then suppose because of the treatment, I start getting exposed to a new kind of content, and I end up really enjoying it. That content might make its way to you. So in that case, you sort of get exposed to the treatment as well. So we refer to this network effect as experimental leakage, and a consequence of this is that our average treatment effect estimator is no longer unbiased. So in our paper, we document the process and results of running the first country-diverted experiment on a major content platform with billions of users in our attempt to ensure better mitigation of this leakage. The expectation is that the between-country network effect is significantly weaker than the within-country network effect. So that way, the feedback loops are a little bit more self-contained. So because you can think that if I'm from France, I'm more likely to be similar to a user who's also from France than a user from Bolivia, for example. Our contributions are twofold. We propose a highly adaptable strategy for setting up country-diverted experiments for large content platforms, and we prove its validity with a live experiment on a major content platform where a significant difference was observed in the conclusions drawn from the user and country-diverted experiments. So one caveat to country-diverted experiments is that we do not expect all country-based diversions to offer the same level of leakage mitigation. So we need some way to screen diversions prior to setup. Since we expect that similarity in content consumption patterns should reflect the degree of treatment exposure, we theorize that the strength of the exposure can be captured as the inverse distance between historical engagement per content source vectors. Therefore, we propose using cosine similarity between the aggregate engagement per content source vectors of the treatment control arms to quantify the degree of leakage, which we denote by L. Here we want to demonstrate the leakage mitigation properties of country-diverted experiments through this proxy metric L. And you see that for user-diverted experiments, this quantity is basically 1, whereas country-diverted experiments typically record lower values. And then in practice, we randomly select a diversion that satisfies L being below some threshold, typically taking that threshold to be around 0.5. So L is bounded between 0 and 1. To account for the fact that our diversion is not selected completely at random, we estimate the average treatment effect via modeling the unobserved counterfactual outcomes using a synthetic control approach. At a high level, the idea is to find for each treated unit some weighted combination of the control unit time series that accurately captures the former's trajectory in the pre-period. In the experiment period, the above combination is used to predict the counterfactual trajectory of the treated unit. We experimented with different ways of constructing synthetic controls, but found that the nearest neighbors method to perform the best. So I'm just going to quickly skip over a slide, but this is the algorithm for finding the nearest neighbors. So once we have our nearest neighbors, then our counterfactual prediction for country C at time point t is basically sort of the average of these normalized time series of its neighbors, and then we sort of rescale and recenter so that it's on the right order of magnitude. And then our average treatment effect estimate using the synthetic control approach is the difference between the observed and predicted counterfactual values summed over the post period or the experiment period. And then because we typically care about percent change differences, we normalize by the sum of the predicted counterfactuals. To derive confidence intervals for this estimate, we follow a version of algorithm 4 from this paper by Arkangelski, which I'm probably mispronouncing. But the general idea is that we repeatedly sample placebo groups from the control group, and then we estimate this average treatment effect multiple times. So we know that they're supposed to be centered around 0, and then we take the standard deviation of those, and then we combine with like a normal approximation, we can generate a CI. So to test this out, we simulated a bunch of 10% country-diverted AA experiments, and we found that the 95% confidence interval gave around the nominal coverage. So onto the application. So obviously, a top-line priority of any content platform is to improve recommendations. And then for the content platform of interest, while product research has highlighted that users wish to be served more timely content, historical A/B experiments where we boosted timely content showed a significant hit to top-line user engagement metrics. And we theorize that we see this because of leakage. Because there is a cost to serving users more timely content because it's generally less vetted, so you might be exposed to a bunch of stuff that's actually not very good. But over time, you sort of discover better, fresh, or timely content. But when we discover that, because of the feedback loops in the system, that gets surfaced to users in the control as well. So in that case, that sort of benefit gets zeroed out to some extent. So to address this hypothesis, we ran a 10% country-diverted experiment according to the described methodology. Typically, content is sourced from a collection of retrieval components. And in this experiment, we restricted the corpus of the largest retrieval component to strictly consist of content published within the last D days for treated countries. And then the rest of the countries got like the control treatment, which is we don't have any restriction on like the age of the content. And then we ran this experiment for around 3 weeks. And then here are the results. Not simultaneously, prior to the country-diverted experiment, we did run a user-diverted experiment with the exact same treatment, and the effect for the top-line metric, engagement metric, was negative. But as you can see with the 10% country-diverted experiment, we did estimate a positive effect. So as a sanity check, we also looked at the average treatment effect for a bunch of placebo groups to make sure that the result we saw was actually sort of real. And we saw that the result sort of lied outside the empirical distribution of the placebo estimates. So one last thing is that we do note that the confidence intervals are notably wide with country-diverted experiments, but that's because we have less units and less homogeneous units. And this is an active area of exploration for us. And then, yeah, thank you for attending, and thank you to my collaborators.
Thank you, Lina. Hope you can continue the discussion on this very interesting paper offline and can reach her. And okay, this concludes this very interesting session. Now enjoy your coffee break before the last session of the day and before the social dinner.